Okay, so the next question that we have here is: a missing helicopter is reporting to have crashed somewhere in the rectangular region shown in this figure. So we have this rectangular region, and it's been reported that the helicopter has crashed somewhere over here in this rectangular region. This length is 9 kilometers. This length is 4.5 kilometers. This length is 6 kilometers. And this length is 2 kilometers. And this is this part over here is a lake, and this part over here is a forest. So this part over here is a forest, this part is a lake, and the helicopter has crashed somewhere in this rectangular area. So now the question that we want to answer is: what is the probability? What is the probability that it crashed inside the lake, that the helicopter crashed inside the lake, So what's the probability that the helicopter crashed inside the lake? Now the solution here is that the helicopter is equally likely to crash anywhere in the region. As far as we can tell, the helicopter is equally likely to crash anywhere inside this region. And the area of the entire region, entire region is basically 4.5 times 9 square kilometers, which is the same thing as 45 times 9 is equal to 9 times 9 is equal to 45, 4, 9 times 36, and 40.5. That's 40.5 square kilometers. And the area of the lake is equal to basically, so this is 9 kilometers, this is 6 kilometers. That means that this part over here is 3 kilometers. This is 2 kilometers, this is 4.5, so that means that this part over here is 2.5 kilometers. So that's 2.5 times 3 square kilometers, which is equal to 7.5 square kilometers. Now the event, I can define an event E, that the helicopter crashed inside the lake. That the helicopter crashed inside the lake. So then the probability of this event would be all the possible outcomes of the experiment, which is basically that the helicopter could have crashed anywhere within this area, and the area of the whole piece of land is basically 40.5 kilometers. 40.5 square kilometers, divided by the basically and the outcomes basically favorable to E would be that the helicopter crashed inside this lake, whose area is 7.5 square kilometers. These two you can cancel out, and then if you basically divide these numbers together, you can write this as 75 divided by 405, and 75 divided by 405 is equal to 0. And 750, that would be 810, so that's 1 times 405, that's 4, that's a 10, so that's a 5, that's a 4, that's a 345, another 0, 3450, 7, 8, 9 times, 8 times. So 8 times, then you would get some remainder here. So that's 0.2. So that means that there is a 20% chance that the helicopter crashed inside the lake. Okay, so that's basically how you can use the idea of probability for the kind of concepts where there are an infinite number of points, and that's basically how you can use the concept there. Or as another example, let's say that a carton consists of 100 shirts, of which 88 are good, 8 have minor defects, and 4 have major defects. Jimmy, a trader, will only accept the shirts which are good, but Sujatha, another trader, will only reject the shirts which have major defects. One shirt is drawn at random from the carton. What's the probability that it is acceptable to Jimmy or it is acceptable to Sujatha? So the carton consists of 100 shirts. So you have 100 shirts there. And from these 100 shirts, 88 are good. 88 are good. And 8 have minor defects. And 4 have major defects. So now Jimmy, who is a trader, he accepts the shirts, the shirts which are good, accepts the good ones, and Sujatha will reject the shirts which have minor defects. So rejects the shirts which have minor defects. So Sujatha, another trader, will only reject the shirts which have minor defects. So she only rejects the shirts which have minor defects, meaning that she accepts these ones, the major defects, and the good ones. Jimmy accepts only the good ones. Right? Now, one shirt is drawn at random from the carton. What's the probability that it is acceptable to Jimmy? So if one shirt is drawn at random from the carton, what is the probability what is the probability that it is acceptable to Jimmy. So if the shirt is supposed to be acceptable to Jimmy, that means that we said that Jimmy accepts the good ones. That means that another way of saying this is that what is the probability that it is basically good. So now I need to create an event here, for example E1, that the shirt is good. That the shirt is good. And to calculate the probability of E1, I take all the shirts that I have and then only the ones that are favorable to this event, which is 88. So that is 44 to 50 or 22 to 25. So that's 22 to 25. Which is the same thing as 22 to 25 is equal to 0.88. That is 0.88. That means that there is a 88% chance that the shirt is good and that the shirt is acceptable to Jimmy. Now, what is the second part of this question is what is the probability that the shirt is acceptable to Sujata? What is the probability that the shirt is acceptable to Sujata? Meaning that acceptable to Sujata, meaning that it is either a good one or it has a major defect, but she doesn't basically accept the ones that have minor defects, as we discussed before. So that means that the shirt is either good or it has major defects. Now, that means that Sujata will accept the ones that basically the outcomes favorable to Sujata would be these 88 shirts plus these 4 shirts, right? So if I want to calculate if I create an event that the shirt is either good or has major defects, or has major defects so then if I calculate the probability of E2, I will get basically the total number of shirts there, which is basically 100 shirts, and over here I have basically all the shirts favorable to Sujata, which is 88 plus 4, so 88 plus 4 is equal to 92 divided by 88 plus actually it's supposed to be basically we said that Sujata rejects the shirts which have minor defects. So she rejects these ones. So that means that these ones are not favorable to her. So the number of outcomes favorable to Sujata are 88 plus 8. Let me see. Oh, I was actually wrong about my condition about Sujata. Basically, what Sujata does is that only rejects the shirts which have major defects. That's what she does. That has the shirts that have major defects. So what that means is that basically the outcomes favorable to Sujata are the good shirts and the minor defects one. So that is basically 88 plus 8. That is 88 plus 8. And that means that basically that is a 16, so 96 divided by 100, which is equal to 0.96. Which is 0.96. Okay, so we have another question here. Which is basically the last question here. It says that 2 dice, one blue and one gray, are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of the dice is 8, 13, and less than or equal to 12? Okay, so you have basically 2 dice. You have 2 dice. Basically one blue Okay, so now basically we have 2 dice. One of them is blue and then one of them is gray. And one of them is gray, and they are thrown at the same time. They are thrown simultaneously. So now we want, first of all, we want to write down all the possible outcomes. Write down all the possible outcomes. So basically you have this, let's suppose that this is your blue dice and this is your gray dice, and the different outcomes of your dice are basically are 1, 2, 3, 4, 5, and 6. And the gray dice has basically the same type of outcomes, meaning that you have 1, 2, 3, 4, 5, and 6. Now, if you have, basically, you could have, for example, 1 with, basically, on the blue you can get a 1, on the gray you can get a 1, so you would get 1, 1, 1, 2, 1, 3, 1, 3, 1, 4, 1, 5, 1, 6, and then 2, 2, 1, 2, 2, and so on and so forth. So you get all of these different possibilities. You get all of these different possibilities. Now, what is the question that you want to answer is, what is the probability? What is the probability that the sum of the two numbers, appearing on the top of the dice is 8. So what is the probability that the sum of the two numbers is 8? So you see over here, you can go all the way up to 7 here. You can go basically all the way up to 2 plus 6 is equal to, for example, 8, right? So this would be 2, 6. This would be basically one possibility. And then over here you will get, for example, 3, 5, which is, for example, 3, 5, that would be another possibility. And then over here you have 4, 4, that would be another possibility. Here you have 5, here you have 5, 3, that would be another possibility. This would be 6, 2, this would be another possibility. So you have 1, 2, 3, 4, and 5 outcomes in favor of this probability. So I call this, for example, E1. So P of E1 is equal to basically 1, 2, 3, 4, and 5. And all the possible outcomes of this experiment is 6 times 6, which is equal to 36. That's 5 to 36. And what is the probability that the sum of the two numbers is 13, for example, is equal to 13. So I call this P of E2, or I can call it P of 13 as well. So P of E2, now 13 would be, for example, 6 plus 6 is equal to 12. And you can go all the way up to 6 plus 6 is equal to 12. There would be no higher number than that. So that would be 0. That would be an impossible event. And less than or equal to 12, less than or equal to 12. So less than or equal to 12 would be basically, that means basically all of these possibilities, all of these outcomes are less than or equal to 12. So when you get all the way up to here, this is 6 plus 6, which is equal to 12. And all of these outcomes, anywhere you choose here, that's some number less than 12. So that's basically P of, for example, E3. You can take it as 36 divided by 36, which is equal to 1, which is a certain event or a sure event. So this you can call an impossible event. This you can call a sure event or a certain event. A certain event. So and that's basically all that we have here. Now this part is done. This was, I suppose, class This was, I suppose, class 10, the review that we did on class 10. So now the next part that we have here, of course, our review is done, and now we can basically go to class 11 and start with probability class 11 chapter 16. I'll see you in the next video.